Previously on.
In my last video, I explored the evolution of reactivity across various frameworks to understand how they all, except React, arrived at signals. There's even a proposal to include this feature in ECMAScript. Now let's examine how each framework implements signals by building the same small component in Vue, Solid, Angular, Qwik, Svelte, and finally in VanillaJS using the polyfill from the TC39 proposal. The component will convert predefined currencies. You can enter the amount in an input and click a button to change the rate. As a side effect, we will draw confetti. Let's start with Solid, as it was the first to be built with signals from the get-go. We will use the V template, download dependencies, and run the project. Next, we are adding our currency converter TSX component. The primitives that Solid provides are createSignal, which we will use for the amount and the rate, createMemo, which caches the value and updates it only when the dependencies change, and createEffect for side effects. There is also createComputed, which is used to build other primitives and to set signals within. We will install the confetti package and types and add them to the effect. The effect watches the used signals, so we will just walk them to track them. Now let's return the template. Nothing out of the ordinary here. We use the getters and setters of the signals and call the update on click. Finally, we add the component to the root component, and bingo bango bongo, we have a reactive currency converter. Next we will go with Vue, as it had signal-like reactivity at its core since the beginning. We create a Vue app following the scaffolding tools instructions, install dependencies and run the project. Great, now let's add a Vue component. In the script we use ref, computed and watch. Here we access the ref using value instead of getters and setters. In the watch we explicitly state which references to track. In the template we use two-way data binding for the input and Vue syntax to use the refs. We add the component to the start page, and voila! Now we move to Angular, which makes the most drastic change by introducing signals, quite different from the Zone.js dirty checking reactivity. After creating a new project, we use the CLI to create a component, so we don't have to add all the files by hand. The primitives in Angular are signal, computed and effect. When we access the signal, we call it as a function and use the .set to change the value. The rest is similar to the other frameworks. The effect watches the used signals, so we will just walk them to track them. Throw that confetti. Let's quickly go through Qwik. We create a project. Here we get a dad joke for our troubles, which is much appreciated. We create a TSX component. Here we have useSignal, useComputed and useVisibleTask. In Qwik, all the components start on the server and continue on the client, so we need a hook that is executed on the client. We specify the values that we need to track and use everything in the template. The final framework of the video is Svelte. In the latest version of Svelte, they introduced runes, which are the reactive primitives: state, derived, and effect. The effect needs to use the state in order to track it, so we log it. In the template, we don't call value but simply use the variables. Lastly, we are going to look at the TC39 proposal. I've built the same component, but this time as a web component. Then I created the signal using signal state and signal computed. Effect isn't implemented because it's tightly coupled with how the framework is going to use it. However, there is an example implementation which wraps computed and uses a low-level watcher for the signals. We combine all that and throw confetti one last time. Now that most frameworks use signals, integrating them into ECMAScript could mean sharing the state created in one and using it in another in a micro frontend setup. There could also be common tools for visualization and debugging of the reactivity graph. Exciting times lie ahead for the frontend world, uniting all frameworks. In order to make this video, I did many npm installs, which cost me much electricity, bandwidth, and nerve cells. If you enjoyed the video, any interaction would help the algorithm and would be much appreciated.